Hi everyone. Good evening. Good evening, everyone. Hello, hello. Let's get this started. Start. Share the P file format. Why doesn't it? So. It's an interesting memory because maybe you're familiar with this poster that I made ages ago, 2012, around this, based on a file that I made in 2009, if I recall correctly. And yeah, why not actually just speaking about it? Um, oh, bonsoir, Henri. And yeah, so this file format, why does it rotate? It should be rotate. It should do a slideshow. I did a few versions, including the Arabic one, which was a bit interesting to do. Yeah, so basically the high level, and yeah, basically the P file format. Um, yeah, let's see. So yes, so you're familiar maybe with this poster that I mentioned again. These posters, it's on the posters and other drawings that I did that I will use tonight are on my GitHub pictures, called Pics, and same address as usual. And there is also a few interesting proof of concepts that are on Kokami Pox, POCs, and the P directory, obviously. And yeah, so let's look at the P file format. And the P file format, let's close this. Uh, P file format. Well, it's just a small evolution of the. I mean, no, okay, not a small evolution. Sorry. No, the opposite is a very big. The MZ file format was pretty simple. The DOS executable file format was pretty simple, and suddenly they extended it. They extended it in many ways that we saw new executables, linear executables, and so on. And suddenly they added not only the same thing again using the pointer out of set 3C again, but suddenly the P expanded to be a lot more. But I mean, from the very beginning, right? If I recall correctly. And today we're just gonna start because unlike the all the MZ file, the executable file format is pretty simple. The P file format is not that simple. It's definitely not simple. Even worse when you consider that then they added the .NET stuff and whatever, so it became really, really big. So I mean, and complex, which is exactly why I did two posters out of it, a minimum. So instead, rather than flood you with all the details, let's instead go to a very, very small executable that is artificially small. No standard MZ should be that simple. No standard P should be that simple. This is the mini file. So yeah, that's it's very not big. Oh, this is actually too big here. Uh, this is unneeded. Sorry. So yeah, a very small file. What is it? 510 bytes in decimal. But yeah, this is voluntarily artificial. I made this file by hand. The source is actually available. The source was done in raw assembly because that's how I did things in 2009. And yeah, so basically, this is exactly why this file is super simple. And but at least it will give us a decent introduction, and this file works. So uh, simple. No, that's not simple. That's mini. And how do we know that it executed? Because it returned 42 as an error. So if you do CLS hello, so you enter a wrong command, okay, and maybe now error level is very weird, but mini actually worked. I mean, we will see what it does, right? So a very small file to start very easily, but yeah, this was necessary to if you want to do a poster that an illustration that fits on a business card basically. but still it works, as we just proved. So the mz the PE file is starts with the DOS executable, the MZ header, and I have also these my two posters, P101 and the one that you know. I mean, the one that you know. You may know both, P101 and P102. P101 is about a specific example, so we will. It's about an example that is slightly more complex that we will cover later, and oops, so that's it's an actual file, and yeah, it has a bit more content. For example, the mini file doesn't have sections, and on the other hand, P1 and 2 is actually looking at all the structures in details. I mean, even it's mentioning everything except even when they are not interesting. So at the offset 0, we have the DOS header, the image DOS header. And from the DOS header, even though it used to be like a lot of important data, of course, for DOS execution, in the case of P, it's actually not important at all. So basically, it can be wiped. You can take a DOS, you can take a normal executable, you can remove, you can wipe its DOS header. It won't be a problem. The only important thing are the magic MZ for Max Grivovsky. Sorry for the pronunciation, and then the whole DOS header. It was until 1A in the until 1B, sorry, in the original DOS header version. Then Windows added a few things. Where is it? Windows added a few things. If you recall, in the previous stream, overlay number, and then there is some resource and OEM ID and OEM info, OEM, and these things are not necessarily used, and in any case, they are not relevant to P execution. So, and then after all this, at offset 3C, there is the pointer to the new structure, and we saw that this pointer could be to where is it? This pointer could be to a new executable. Here, it's pointing to a pointer with the any initials, or the LE executable, LX for the linear executables, OS2 and others, and even more like yeah, W3, W4, but those are rare. But anyway, yeah. So anyway, so there now you have a pointer. You have how can I say? You have at offset 3C a pointer to the next structure, and let's turn back to offset mode, and this pointer is just a double word pointing to the next structure, and the next structure is the thing called. So we call it the P header because it starts with the P signature, but in practice it's called emergency headers. It depends if it's just an object or if it's an actual full P binary. But yeah, won't go into the details. And there's image file header, which is followed by the optional header, which is not optional in the case of an executable. And then following all this, P header, there is the table of section, which is very important for mapping. Let's zoom out. Which is very important to map the process into memory. But as we will see, we use here a magic trick so that there is no section table. I mean, a magic trick, yeah, known trick, but so a DOS header, which is points to a P header, which is followed by the optional header, and then that's all to just make a minimum executable P file. Okay. So as you saw in all this, there is plenty of fields that may be irrelevant, and that's why I made a few bigger than others. Some are like totally irrelevant, and so which is exactly why this file here is functional. even though it seems to be much less complex. So we have um, the P null signature. Then we have the so as you see, Hue is showing already a lot more information and is showing everything, but most things are set to 0. The machines, uh, P was on many platforms. Many I have never tried actually. So machine is super important, defining the architecture of the binary. Then the characteristic, so that it's executable, it's a bit field. Okay, we don't have mappings of bit fields in Hue. Okay, and then magic for optional header, which is another way to say if it's a 32-bit or 64-bit. Let's show why. Because the optional header changes size if and order if depending on the how many if it's a 32-bit or 64-bit architecture. I think there is an exception for the very old DEC Alpha architecture, which was 64-bit anyway, but not using this kind of header. And yeah, it's not everything is not clearly mapped, but at least the size of the size of the magic is saying, the magic of the optional header is saying if it's 32-bit or 64-bit. But the weird thing here, I set one here. Oh no, I didn't set one. Oh, because I don't need it. Okay, but in a standard piece, you have this size of optional header, which is not actually the size of optional header, but which is used to jump from the beginning of the optional header to the section table. So everything is a bit confusing in the P file because nothing is working fully the same way, and there are it's a lot of quirks. And again, this file itself is very quirky because it's lacking a lot of information compared to a standard file. As I mentioned, no section and so on, and no size of optional header is here. So there is a magic to say if it's a 32-bit or 64-bit optional header. Then important is the entry point, to just tell the software where to start the execution, of course. And here, very simple, put 42 in EX in return, which is an equivalent of exiting the process with this error, with this return code. And very important too, and twice important in our case, the section alignment and file alignment. And you will notice that they are very small. And usually in a standard executable, in a standard P, the file alignments are 1,200. And if these two alignments are actually very small, like smaller than 200 or less, then we enter the not so documented driver mode, where actually a section table doesn't matter and everything is mapped directly, which is something I abused a lot in the past. And let's see if I can find it actually. I had created this very weird I created more than a few. Now this one is okay. Nope. Will I find it? Nope. Okay, I can't remember which one it is, sadly. Basically, you could you could make ASCII art with the section table because again I'm trying to find it. So basically having a low alignment makes the section table ignored, which is why we can have such a small P file in our case. Still trying to find. Nope. Okay, so we have very small file alignment, and then which here setting it to 1 give us no constraint at all. And then we have a subsystem version major, which is important, which will say which version of the OS we run on. And in our case, it's a requirement. I had this regedit from Windows 95. I assume that even on this regedit, the version was 4, but let's see. Yeah, again, yeah, from Windows 95. So I think 4 means Windows 95 and later. I don't know when it was. Maybe NT, because there were P files were already on Windows NT. So yeah, and then the size of image, which basically says the whole size to be loaded in memory and the size of header. And also, lastly, important, subsystem, which means um, if the system is a driver, it has a GUI, it has a console of Windows with it or not, and other kinds of subsystems. So very critical. And that's the last element of the size of optional header that should be set. Then the rest can be actually not so set, which is why if you see it's offset 9C, I created once a file where the file was stopping there, and because the rest was initialized memory, it was set to 0 even if the file was truncated there. But this kind of file doesn't work on under modern Windows anymore. So from this, this is a whole PE. It works, but this is extremely simple. But we already explored a few quirks, so especially this file alignment thing. Now let's jump to a bit more complex file, and that's the file that was in the poster, in that poster. So this one, and here now we have a more realistic P file, which is or what is it? Which is sorry. This resizing would be better if automated. So okay, that's the whole file. I mean, and then it's made of headers and sections. Now we're gonna use the actual section mapping, which is very important to PE files, which basically via the section table tells where each which part of the file is mapped to where. Very, I mean, nothing too complex here, but a very standard uh, idea concept in executables. Then there is again the DOS header, that should be at offset 0, the one starting with MZ. Then there's a P header and the optional header. And the data directories, I didn't mention them earlier. They are this list. It's a list, but every entry in this list is a very specific uh, as a very specific role. So they all have the same structure of just being a value. So the value can be a relative virtual address or an offset, but and a size. But actually every entry has a different role, is pointed to a different structure in practice. So the data directories, typically you would see them for export, import, maybe resource. I mean, you see that I show them with different importances depending on their role in the in standard P files. And then there's the data directories, and then there is a section table, and the section table is again responsible for the mapping. Oh, can I? Oh, it doesn't work. Can I? No, stupid thing. Come on. Let's see. Can I do this? Can I do this? This remapping thing is not so handy. Okay, so the section table. Oh yeah, this is not super handy to zoom on this shit. Adobe failing me again. Okay, so we have the dump of the DOS header, and there is again I only initialized the magic, and the pointer to the next value, to the next header. Sorry. Then in the, I'm going to try to zoom it differently. So you have the DOS header, the P header, sorry, and in it you have uh, only a few values set, but this time we have a size of optional header to tell where to find the section table after the start of the optional header, and the number of sections. So a bit like before, but now we have a number of sections. It's like we do the enter and the pass. Yeah, maybe. So now let's look at the, yeah, it's not easy to do this. That's the optional header, and we have the magic that tells the if it's a 32-bit or 42 or 64 bits optional header, the address of entry point where execution start, then the image base, the section alignment, but this time they have a proper uh, um, values like 1200 in hex. And again, the section alignment is where the section should be mapped to in memory, the alignment of the mapping in memory. And the file alignment is where to find the section, the alignment where to find the section on the file itself. So no big difference compared to the mini file we had earlier, except that this time we have a number of RVAs and sizes, which is 16. That's the standard value, so that we have a standard data directory um, list array. But we don't use all of them. We only use a very few here. And here, this is exactly what we're doing. We just have only the second entry. So the first entry is export, and the second entry are the imports. So you see that every entry is disabled when the RVA or the size are 0. So basically, we only use the export one, and it shows that there is 16 of them because I have a number of directories that is set to 16. But I could make this smaller, even though it's not a trick that is so much used anymore. But we you could just make this value smaller. Where is it here? And the file would still work as long as the data directory that you're using is relevant. So here, because I'm using the second import, I could just set number of directories to 2. And so now we have the import, and the import is this system to, I mean, load in advance addresses of functions exported by other DLLs, a DLL being the library version of a PE file. So basically, some functions are in DLLs, they are exported by these DLLs, and by writing an import table, the system is asking, hey, put me the address, load this DLL in memory, and put me the address of this function at the right position. So the way it works is, this resizing is annoying. This resizing is definitely annoying. I won't use it next time. Okay. So this is an import table when from the pointer to from the second entry in the image data directory array, then it points to a sequence of import image descriptor, which is one pointer, timestamp and forward chain that are not used anymore, and then a name, a pointer to an actual string of the name of the DLL, and then a pointer to a thunk. And basically, the two thunks will be used in parallel to basically to tell which name of which function should be put where. You see, it's building a table in memory, which is called the import address table, and which is actually pointed by the import address table is optionally pointed by entry number C, if you see here. I'm not sure if it's readable. So basically, the import is a small sequence of structures to make automatically the OS load the value, the proper address. First, load the DLLs, initialize them. I mean, run their entry point, and load the resolve the put the address of the API that be imported at the right memory, so that then it's directly useful. And when you look at the code, basically, uh, this code here is actually importing two APIs, and from two different DLLs, and the whole process here, it knows that it's it will be message box and so on, because if we go to the import table, we have again this structure. So of you see, first thunk, and the name, the reference DLL, and where the address should be in memory, and this call is actually pointed to that address, so it knows that after loading, this is the name. This is how the disassembler can tell, hey, this will be this API being called, because the import table is saying this API, this function of this DLL, the address will be put in by the loader, by the system loader, at that address, and therefore the call will magically happen. So a transparent system, so that now you can, I mean, for example, you can have annotated source. I mean, annotated. It knows that this call will actually. You remember when you saw earlier, we actually saw this address in memory. Uh, um, 40270, and this is the import table. The import structure is the one telling the OS, put this address at this point, at this address in memory. Put the address of the API at this address in memory. So now, what else? So we have this small file. Now, what else? Yeah, it's not very handy to navigate that way. So again, we have this structure. So we have oh yeah, sorry for that's the RVI and the import. Now after the end of this optional header, there and therefore the after the data directories, there is the section table, and the section table is a sequence of of uh, is a sequence of the name, a virtual size, the virtual address, and a few other things. Not everything is important. As you see, there are some parts that I haven't highlighted. In the P102, you will see it fully. So there are some stuff that is related to debugging, pointer to relocation, pointer to line number, and so on. But very important, the important ones, the name is not critical, is mostly decorative. Virtual size, virtual address, the first four ones to help the OS to map the file in memory, and then the characteristics is the one that says, is this section executable or not. So the attributes, but here it's, I cannot edit them. I mean, Hue doesn't tell which is one mapping to what, but basically it's is it executable and so on. Is it initialized? Ah, yeah. Code, is it code? Is it executed? Read only, write, and so on. Okay. So here, 3 entries, but you see some items are not used by standard Ps in general. Then I put some code. Okay. The code is fairly simple. I mean, we saw it earlier. Calling the message box API with 4 parameters, but obviously the important ones here, I mean, the ones that we set are the address of the text to be loaded, to be shown, and yes, it okay, it cannot execute because I'm, yeah, super sexy hello world. And after that, we have the import, which is yes, again, oh, it's rendering. Yes, if I'm holding the button, it doesn't finish rendering. I have to release the button so that it renders. Wow, awesome. So The descriptors. So do you have the two import descriptors for the two DLLs pointing with the central I one of the central memory. There are a few more if you remember. We can see it here, but again, it's not great to navigate between two files. And then yeah, the last descriptor I forgot to mention should be null. And yeah, then after that comes um, the text information for the names of the APIs. Okay, so we covered a very simple um, executables, PE files. Now we could go for a small, a more complex one. But before, so again, I started with this extremely simple one. Now to this one that has a section table and so on. But an actual PE file looks like this, and you see that so that's notepad. You see that the values of the DOS header are filled with information. Usually it's always the same information. This information can be set to 0 and the file will still work. Then, because this is an actual, remember, this is an actual executable. We covered that in the previous stream. This is 16-bit code to just display uh, the string. This program cannot run in DOS mode. And then there is this structure that is called the rich header. It's called the rich header because it has a rich signature here. And this is just, there is just a small XOR mapping, and this is the XOR mask. And these are just debug symbols, information about the process. This is useful for debugging, but absolutely not important for execution. So this can be moved, and then comes the P header. A P header, a standard file, will have a lot more sections. But after the all sections, the process is a bit the same, except that again, a lot more informations will be used by the data directory. I will not cover that today. Resources is where the icons and the bitmaps are stored. Exception is a pointer to structure for exception handling, if I recall correctly. Fixups are the locations, like telling when the file is moved to a different address in memory where it should be. Again, this is an official Microsoft debug, so plenty of information. I will not cover that today, definitely not. But yeah, and still some stuff from the past, MIPS. So this is a more complex PE file, but to be honest, the file would still work if we just, of course, except that one here. But if we just fill all these with zeros, this file will still work. So at least it's not, don't be too impressed. It's not so important from the P perspective. And then the P file itself is not so complex, except that, of course, a lot of information will be populated. Okay. Do you have any questions? Because I don't want to dig too much in P, especially the first the first time. When you send the content to 0, how does it still work, and how do you do that? How do I do that? To wipe the file to 0, or to let's see. Let's take one of my files. I think that was the one that was called normal. Okay, the normal is not so normal. um, Oh yeah, you know what? Doom. Of course. Of course. Let's take our Doom polyglot. Oh, I don't know if you saw, I made public yesterday or this morning. Where is it? So my Doom polyglot that I showed in previous stream, and this is a. Oh come on! No, oh shit! Sorry. I forgot the no window parameter. Okay. So time is the charm. So that's a Doom. So that's a P file. And so, okay, this is not the most standard P, but if we want a very, so that's the polyglot that I presented in last stream. Maybe not the most standard P, not that I have to admit, but it's a P file, right? Even though it has a few. Oh, come on, it's still running. Oh yeah, it's running. Come on. We keep torturing the Doom binary, and it's fun. Okay, so this is still a P file, right? And it's still following the same rules. So until from 0 to 3C, this is we can fill it. And after 3C, it's nothing important until the P header. And we see that the P header, the offset here is 1AC. So, and indeed, we have the P signature. We will remove the signature from Neo, which is Robert Xiao's handle. So fill to 0. And we see that our header is mostly full of zeros. I mean, these parts are full of zeros. Not the best example compared to standard. It's not the most standard P, but it should still work. Of course, except that now that I have the antivirus is catching that it say, hey, this file is weird. No shit. So this file still works even if most of the PE file has been wiped. And importantly is that you can move stuff around. Nothing prevents you to move the PE header a few bytes further, as long as the alignment of the section is still the correct one, you know? So if you move if you move, what's this? Why there is MZ? Oh, maybe it was a mistake from him. Okay, 1AC. There's two. Oh no, that's a docs extender. Oh yeah, that's true. There are two files in this file. It's definitely not the most standard file to play with its P header, but that's the one I had close by me. Okay, do we have any questions? Any further questions? I think we had enough fun with P files. We went from very tiny files to Doom weird executable. No questions? Okay, then I guess that's all for today. That's all I have for today. And yes, I hope that was an interesting and introduction to the P file format in a way. And remember that my posters about P file formats are available. I forgot one thing, one very important thing, one very clever thing. So you saw that the P header has all these fields that are full of zeros and they are not so relevant. And this is exactly what the idea behind the terse executable file format TE, which is not related to Windows, but it's related to UEFI. And basically, if you see, I assume designed by Vincent Zimmer, and the idea, if you see that it's following even the same names, machine, number of sections, script size, and so on, but it's a very tiny file format that just basically is a stripped down P header structure. And the great idea is that even because it used the same names, it's pretty easily to understand where it's coming from, and that's the idea, so that it could benefit the whole tool chain of P generation, and then you just need one single software to convert a P to a T. So I think this is a very clever idea, because in a standard P file you have plenty of manipulation where you could put really whatever you want, as you saw with the Doom polyglot. And in the case of the T file, do I have a T file? I should have one. Draw output. Do I have a TE? No, I don't have a TE file. I should have. Maybe in my POX directory. Sorry for that. No, I don't have. Where do I have this file? Okay. This is weird. Okay. But anyway, you see that the structure is based on, so you see that even have section tables and so on. It's based on a P file, but it's stripped down. And basically that prevents that get rid of a lot of information while not entirely creating a brand new file format. It's a very clever idea so that you can reuse all the existing tool chain for P files, and there are a lot, and then you just need in the end to convert to your new file format. I think it's a very clever idea, and definitely it should be done to avoid further abuse. Like it's basically a projection, a stripped down version of a format. It doesn't really look like a brand new format, and I think it's a very clever idea that should be done on other formats that are full of abuses, like we saw, like zip and PCX and others, or GIF to make parsing easier. So basically, projecting files to a newer sub format would be a very good idea to remove a lot of engineering headaches while still benefiting from the original format. So really a good idea. What about OS2 executables? What about them? That's a question. OS2 executables, they are linear executables, so it's totally not. Um, that was a question from Chaboté. And let's see, where do I have this? Linear executables, it's a completely different format. Oops, what happened? It was supposed to show me the. Come on. So there's DOS header, but then it points to no. Why I'm pointing to? It's showing me the LE, and then okay, and then it's completely a different structure. I actually have a OS2 executable in my posters on my GitHub, but as you see, it has nothing to do with PE file format. It just shares the original DOS header and the DOS stub, but that's about it. So OS2 executables is an entirely different thing. I mean, okay, actually, OS2 executables, they exist in different flavors, but it doesn't. I think usually they are not P files at all. They are OS2 is older. Okay, so thanks for your attention. I hope you had a good time. And yeah, next time maybe I won't use. Maybe I won't use. Oh, the rendering is frozen. Maybe I won't use Adobe for the zooms things. And yes, see you next stream. Bye bye, everyone.